The topic is electric field. What is an electric field? Now, in our previous topic, electric charge, in that topic, we learned that when you bring two charged bodies close to each other, something happens. They either attract each other or they push they either attract each other or they push each other aside. They either attract each other or they repel each other. Now, that tendency for charged bodies or bodies that are brought near a charged body to either be attracted or repelled or pushed away is related to this particular topic that we are looking at, electric field. So if you bring another body close to a charged body, you will notice that the tendency to attract or to push away, the strength of that tendency, the strength of that tendency is not equal. What I mean is, the closer you bring that body to the charged body, the stronger the tendency to either attract or repel. But the farther away you take that body away from the charged body, the weaker that tendency to attract or repel. So in this topic, electric field, the region that describes the area where this force is experienced, the force of attraction or the force of repression or repulsion, around a charged body, the region around a charged body where this force is experienced, is what is referred to as an electric field. So an electric field is a region around a charged body in which another charged body experiences an electric force. So examples: when a positively charged object attracts a negatively charged object without touching it, the interaction occurs through an electric field. Electric field strength. Remember I said that the farther away you take away a body that you bring close to a charged body, the farther away you remove that body away from the charged body, the lesser you experience the force that attracts or repel. But the closer you bring a body close to a charged body, the stronger, that tendency to attract or repel. So that tendency, or rather this phenomenon, is referred to as the electric field strength. So the tendency to attract or repel is stronger when you bring the body close to a charged body, and weaker the further away you take the body from the charged body. So that behavior or tendency is referred to as the electric field strength. So the electric field strength is the force acting on a unit positive charge placed in an electric field. And the symbol for electric field strength is E, while the unit of measuring electric field strength is Newton per coulomb. The formula for electric field strength is E equal to F all over Q, where E is the electric field strength, F is the electric force, and Q is the charge. So now that we have mentioned it, the tendency to attract and repel is a force. That force is referred to as electric force. Now, the area where you feel that force around a body, around a charged body, is the electric field. The region around the charged body where you feel the electric force is the electric field. Electric field lines. Electric field lines are imaginary lines. Look at this diagram. This is an electric field. This electric field is described with the electric field lines. So the lines are imaginary lines that are used to represent the direction and the strength of an electric field. So these lines describe the electric field, and then it describes the direction and the strength of an electric field. What we are seeing in this diagram is the electric field that is existing between a positive and a negative charge. The properties of an electric field lines. The electric field lines, they originate from the positive charge and they terminate on the negative charge. Now, if you look at the diagram, you see arrows pointing from the lines coming out from the positive charge towards the negative charge. So the field lines originate from the positive charge and they terminate in the negative charge. That's one of the properties of electric field lines. Another property is that they never cross one another. So if you look at the diagram closely, you'll see that the lines did not cross each other. So electric field lines do not cross one another. Electric field lines also describe the strength of the electric field or the electric force around the electric field. So the closer the lines are to each other, the stronger the force. But the farther away or farther apart they are from each other, the weaker the electric force or the electric field strength. So the electric field strength also indicates the direction of electric force. So from this diagram, you can see that the direction of the electric force is from the positive charge to the negative charge. So we have seen listed here 4 properties of electric field lines. Number 1, electric field lines originate from positive charge and they terminate on the negative charge. Number 2, the electric field lines never cross each other. They don't cross each other. Number 3, they describe the strength of the electric field. The closer they are to each other, the stronger the field. The farther apart they are from each other, the weaker the field. Number 4, they also indicate the direction of the electric force. The electric field around a positive charge. If we go back to that diagram, you can see that from the diagram that we have here, there are 2 charges here. And you can see that the direction of flow or the movement of the electric field or electric force is towards the negative charge. So the electric field lines move from the positive charge to the negative charge. So this means that the electric field lines radiate or comes out of the positive charge. So around the positive charge, you see lines pointing outwards, radiating from the positive charge. So this means that a positive charge placed nearby would repel away because the field is coming out of positive charge. The force is coming out of the electric force is coming out of the positive charge. So if another positive charge is brought near, it will push it aside, it will push it away, it will repel it. The electric field around a negative charge, from the initial diagram, you can see that the lines are moving from the positive charge towards the negative charge. So it's like the negative charge is absorbing the lines, the electric field lines, or it's absorbing the electric field. So what this means is that the electric field lines point inward towards a negative charge. So this means that when you bring a positive charge close to this negative charge, it will attract it. Electric force. Electric force is a force of attraction or repulsion between charged bodies. Like charges repel each other while unlike charges attract each other. So if you bring a positive and a positive charge close to each other, they will repel each other. If you bring a negative and a negative charge close to each other, they will also repel each other. But if you bring a positive and a negative charge close to each other, they will attract each other. Applications of electric field. Electric fields are used in photocopiers, in electrostatic paint spraying, in inkjet printers, in electrostatic precipitators, and in cathode ray tubes. Factors that are affecting electric field strength. The magnitude of the charge producing the field and the distance from the charge are factors that affect the strength of an electric field. The relationship between electric field and charge. The greater the charge, the stronger the electric field around it. Therefore, electric field, or rather, therefore, electric field strength is proportional to the charge. Safety precautions around high electric field. Avoid touching exposed electric conductors. Number one, avoid touching exposed electric conductors. Number two, stay away from high voltage power lines. Number three, use proper insulation. Number four, follow electrical safety regulations. After watching the video, there are 10 questions here to test how well you understand the topic. Question number one, define an electric field. Question number two, what is electric field strength? Question number three, state four properties of electric field lines. Question number four, draw the electric field around a positive charge. Question number five, draw the electric field around a negative charge. Question number six, define a uniform electric field. Question number seven, state the unit of electric field strength. Question number eight, mention four applications of electric field. Question number nine, state two factors affecting electric field strength. Question number 10, differentiate between electric force and electric field. After answering this question, send me your answers.